Hi guys, welcome to my channel. In this video, I'm going to talk about elastic collisions in one dimension. The first thing is about direct impact and Newton's law of restitution. Okay, what is direct impact? Direct impact is the collision between particles when they are moving along the same straight line. Okay, for example, we have a simulation here with ball 1 and 2. Okay, now if I start the simulation, okay, it's a bit slow. We can see that both of these balls are moving along the same straight line. Since they are moving along the same straight line and they collide together, so we can say they have direct impact. Next is about Newton's law of restitution. Newton's law of restitution defines that the velocity of the particles after the collision depends on the elasticity collision and the velocity of the particles before the collision. So what is elasticity collision? As you can see, we have elasticity collision of 100%. Okay, and we have kinetic energy of 0.22 joule. So after it collides, the kinetic energy remain unchanged. Now what if we decrease the elasticity by half? Okay, now we start the simulation. The kinetic energy is still 0.22 joule, and after we start the simulation, we can see that the kinetic energy has been decreased. So which means if the elasticity collision is 100%, then the kinetic energy before and after the collision will remain unchanged. But if the elasticity collision has been decreased, which means it's not fully 100%, the kinetic energy after the collision will be transferred to another form of energy, which is heat energy or sound energy. And since kinetic energy is equals to half mv squared, so we know that the velocity of the particle will have been decreased as well, with the mass remain constant. So the formula for Newton's law of restitution is E equals to VA plus and minus VB divided by UA plus and minus UB, and we call this as velocity of separation, and this velocity of approaching. Imagine we have ball A and B with velocity of UA and UB. After they collide, they have velocity of VA and velocity of VB. And as you can see here, I didn't draw the direction out because the direction of the particles moving will actually affect the plus and minus sign in the equation. The E in the equation is actually the coefficient of restitution, or we can call it as elasticity of collisions. And this coefficient of restitution can only be in the range of 0 to 1. And 1 means 100% of elastic collision, and 0 means 100% of inelastic collision. And the condition for us to use Newton's law of restitution is the particles must be moving in a free space or smooth surface, which is no external force. So now we go back to the simulation. What if we decrease the elasticity to 0%, which means 100% of inelasticity collision? Okay, let's see what will happen. As you can see here, the ball stick together, or we can say they coalesce together which means they stick together to form one big particle instead of two separate particles, and they will move with the same velocity because they are now a one big particles, so they will move with the same velocity. And as you can see here, the kinetic energy has decreased tremendously, and it's near zero, but it's not zero because it's still moving with a velocity. It's just that the velocity is quite small. So go back to the equation. Now I'm going to explain what is plus and minus and how do we identify when we should put plus and when we should put minus. Okay, here we have the first case where ball A and B, this before the collision and this is after the collision. So before the collision, ball A is moving with the velocity of 6 meters per second and ball B is moving with the same direction with 3 meters per second. After the collision, ball A is moving with the velocity of 4 meters per second and B is 5 meters per second. Now imagine yourself sitting on the ball with the lowest velocity, which is the B. And of course, when you're sitting on ball B, you feel that you are at rest because it's moving with constant velocity, so there will be no acceleration, so it just feels like you're not moving at all. And now if you look at ball A, you will see that ball A is moving faster and approaching you by 3 meters per second. Therefore, we know that the velocity of approaching between ball A and B is 3 meters per second, which is 6 minus 3. Okay, what about after collision? So same thing. Now we just need to imagine ourselves sitting on top of ball A. And if you look at ball B, it doesn't feel like ball B is moving with the velocity of 5 meters per second. Instead, it's moving with the velocity of 1 meter per second. So here, you also use minus. So now we know that the coefficient of restitution is 1/3. Okay, now we have the second case. Okay, so before the collision, they both are moving towards each other. Imagine you are sitting on top of ball B. And when you look at ball A, it feels like ball A is moving really fast towards you. So here, we will add the velocity up. How about after the collision? After the collision, imagine if you are sitting on top of ball B and looking at ball A, you can see that ball A is moving really fast away from you. So here, we can also add up the velocity because the velocity of approaching and separation is really fast. So we will add the velocity up together. So this is how we identify whether we should use negative or positive sign. Now, what if the particle collides with the wall instead of another moving particles? It's actually much easier because you just use the same equation, but now there will only be velocity of the moving particle in the equation only because the wall is not moving, so the velocity before and after the collision will be 0 only. So since only the ball is moving, so we can say that to find the coefficient of restitution, we just need to divide v by u, which is the velocity of rebound, and the velocity of approach. And the last thing that I would like to say is, since it's about collisions between the particle, so you will need some knowledge of conservation of momentum, and you must make sure that you have fully understanding in conservation of momentum first. That's all for this video. If you did learn something from this video, please leave a like and subscribe to my channel, and I will see you in the next video.